Thanks, Russell, for the introduction. So, hello, everyone. Today, we're going to talk about the REST spec. I give the names REST Revolution. It's a good name. I think after that, you probably agree with me. Right now, I don't expect you agree with me. So, before we getting started, I get some question for you. How many of you use the Iceberg in your production environment? Raise your hands. A lot of hands. Great. Have you ever experienced the data corruption or table corruption? Oh, that's a lot of. Right. It's good to know. And this is what you expect when you have the table corruption, right? And you cannot find your metadata JSON file. That's very essential piece of the Iceberg table, because without that, your table basically is invalid, and you cannot do read, cannot do write into that table, and everything is done. And it may happen two ways when your engine, like Spark, try to thought the commit it's being succeeded, but actually not. So that's the inconsistency for your table. And another scenario is even more dangerous, which is the engine, like a Spark, thought the commits failed, but it actually succeeded. Then the engine will delete all these related files, like the managed JSON files, all these snapshot files, manifest list files. Then you're going to see this one, and it's not funny, and you're going to be under great pressure to get this resolved. In today's talks, this is the agenda of my talk. I'm going to talk about why do we need a catalog, and a bunch of the traditional catalogs, and the Iceberg's the concurrency model, which is optimistic concurrency. And then I'm going to talk about the REST catalogs, which is the writing thing, the major topic of this session. And then I'm going to talk about the current status of the REST catalogs, as well as the future of the REST catalogs. And I'm talking about one of the core design principle of the REST spec, which is compatibility. Then we're talking about the whole ecosystem. It's actually a bunch of the clients server already doing the Iceberg REST spec implementation, so it becomes an ecosystem. Then I'm talking about new Apache projects, which is Polaris. A little bit about me. I've been working in the open source world for quite a while. I was a Hadoop PMC member. I used to working on resource manager and file schedule a lot. Raise hand if you ever used that before. All right, thanks. And then I'm working for Iceberg for several years, become PMC member. And recently, I've been focused a little bit more on the Apache Progress, which is incubating projects. Right now, as a PPMC member for that project. Okay, why do we need a catalogs? Anybody knows? Does Iceberg work without catalogs? Yes, if you raise your hand, if that is. Yeah, that's correct. You don't actually need a catalog to work with Iceberg table. You can use storage, right? So within the Iceberg report, there's one thing called Hadoop catalog. It's actually not related to the Hadoop. It's also not a catalog. It's just it's a very fun name. And all it does, it's handle one file called a version hint files, right? The version hint file only have one item, which is the path to your version file, or aka metadata JSON file. All right. I guess everybody know the layout of the Iceberg table, right? So for Iceberg table, we have data file written by KORC at the bottom, and in the middle, it's all metadata of the Iceberg table. We have 3 layers of metadata. In the bottoms, it's a manifest file pointing to all these data files. And in the middle, it's the manifest list file represents one snapshot. And on the top of the manifest file, it is called version file or metadata.json file, which is represent each version of that table. And with storage only, table still works. You can use HDFS, S3, but it has some problems. First, it's the poor dressing. You cannot use the engine like database.table to address your tables. And it's a tight cup to the path. Like you have to make sure your HDFS directory or S3 prefix exact same names when you try to address them. We use this kind of database db1.table1. And then second, lack of data governance. Everything is just with storage. Like whatever's permissions, it's always storage. There's no RBACs for your table items metadata. There's no policies. There's no data lineage. Everything is just storage. And as you can see, this blue bar, so everything's written by the engine. It could be Spark, Trainer, or Flink. And there's some compatibility concern. For example, if you happen to have the old clients with 1.3 and a new Iceberg client with 1.7, the potential, the old client just overrides whatever new clients needed for that within your version file. Then new client basically screwed up and you cannot read your table correctly. And also, because it's a storage, tightly coupled storage, then the interface itself is the kind of ad hoc. You have to do the implementation for each individual storage. One of the example right now is if you, like people are really excited about S3 Iceberg table, they call it S3 table. But it turns out you have to write your own clients. And a performance concern, there's minor performance concern because there's no way to caching that. Everything just written by read and write by your engine, like Spark, right? And then we have traditional catalogs, right? Traditional catalogs, usually one of the very popular one is the HMS, the high meta store, right? You can see the orange bar, the catalog getting started into the picture. So the catalog itself, for these traditional catalogs, usually the only thing it does is to store this file point to your version file, as you can see here. And something magic happens because dress table became much easier. You can use db1.table1 to dress your table. And it provides very basic data governance feature, like you can provide catalog level, HMS level, access control, right? And as you can see, engine still writes everything for the Iceberg table, including version files. And in case of any conflicts for when you have the simultaneous writing to that Iceberg table, the engine is in charge of the retry for all these conflicts resolution. Usually they have to lock the table. And that's what happens. In the very beginning, you see the table has been cracked because a lot of times when you lock the table, the lock itself can be expired. And that's usually how a table is cracked. The compatibility concern is still there because the engine is still in charge of writing all these metadata JSON files. And the old client happened to overwrite the new client, or writes the new commits. Then the feature within the new spec will be just to get rid of it, just to override it. And there's no credential value for sure, because basically this catalog doesn't support that. And performance concern as well, because there's no caching, like the engine is still in charge of everything. Metadata files as well as all these data files, so there's no caching could happen. So before we jump into what kind of catalogs we really want for your Iceberg table, I want to deep dive a little bit about the concurrency model of the Iceberg. We call it optimistic concurrency. it's amazing that it's a lock-free approach. So optimistic concurrency allow multiple processes to make change to the single table simultaneously. So each change include a unique version identifier. When someone wants to commit a change, Iceberg itself will check whether this version they get started with is still current. If not, that means another change has been made. So the transaction will need to rebase or retry it with the latest version, right? So this is a lock-free approach. It helps prevent conflicts without requiring locking. So it makes sense for Iceberg to build, because Iceberg table essentially handle a huge amount of data, especially for append only. Like you don't necessarily needed them to lock and to prevent the other writes. You wanted them to run in parallel, right? So this graph shows as this Iceberg table starting with version 1, and the client 1 makes some change based on the version 1 and commit as a v2. Then client 2 makes some change based on the v2 and commit that change as a v3. So you probably already guessed right. It's a happy path. All right, this is a more normal path, right? So when client 1 tried to make the change and commit as a v2, client 2 also use the v1 as a base to do the same commit as a v2 prime. Guess what? If client 1 already commit v2, client 2, the v2 prime cannot get 18 because it's conflict. The base version has been changed. Then it becomes conflict resolution. So we have a bunch of the strategy to the conflict resolution, and it turns out it happens, especially when you have a multiple commits happens in parallel. The more conflicts are inevitable, and when you have faster commits, that means more conflicts. So we need some way to resolve these conflicts as well as to make the commit faster. This is kind of a requirement for the catalogs. So we need a reliable and low latency commits, so that when you can do the fast commit, that means this conflict can be avoided because the second write may pick up the latest commits, and there's no need to do conflict resolution. But still, conflicts still be inevitable in a lot of the times because of the concurrent commits, right? So you still need a better conflict resolution. And I think if a catalog can provide a better context for your table, then that means you can do better conflict resolution. Third one is easy client implementations. For catalogs, we want this client implementation not so hard, right? We want to use very standardized things to do the client implementation. That means you can have more clients for your Iceberg table, not only about the engine, Spark to writing ETL pipelines. You can have Flinks as a streaming. You can have the Python clients to get the metadata, all kinds of clients. And then for the catalogs, you also the big catalogs here is their governance. You want to do the RBAC, you want to do the file grant access control, you want a tagging table, you want to do the combines, right? This is basically, or you want to do the audit, table maintenance for your table, right? And this is all requirements for the catalog. So about 3 years ago, the committee is getting started with the scratch of the starting to come up with the solution with called a REST spec. And based on the REST specs, we try to build the catalog called a REST catalog. So as you can see, the idea is pretty simple. If you look at the bar, the catalog bar is orange bar, it's extend a little bit. The engine bar is shrink a little bit. So that means right now, engine is not in charge of the return the version file. And the catalog does it, right? And these very simple chains make big difference, actually. Let me explain a little bit more. So by shifting the client responsibility to server, we actually server side actually handle the commits and retry. There's no need for lock your table, right? When you do the HMS, you have to lock the table. That's usually what happens for corruption, and it usually faster and more reliable. And it also, the server side writes the management file with a change-based approach. So every time you update the table, you actually don't send the whole version file to the server side. You just send your change. For example, you do DDLs, change your schemas, you send schema change to the server side. That's only about that particular change. And with that change-based approach, it reduces risk, compatibility risk significantly. Because as long as your server has the same version, all these version files being written by the server should be compatible with all clients. And it improves the decision making at the commit time. Because right now, the server has better context. And for example, you have DDL and DML, one append, one just change schema, or you change some table property. They don't have to conflict with each other. The server side can reconcile and merge them in the server side. Other than the client side, the client have to do back and forth with server to make sure that happens, right? And when you have different commits for the data files, you can actually reconcile them as well. For example, if you have like you ever experienced the compaction versus ingestion, right? For compaction, we usually always prioritize ingestion over compaction. Compaction we consider as the non-op. And this is much easier done from the server side. You can, when you see the ingestion coming in with a base version that is one of the compaction base, you can just remove that compaction. You can do a compaction a little bit later, but you don't want to fill your ingestion pipeline. Another use case is multi-table transaction. This is only can be done by the REST catalogs because only the server understanding all these multiple tables within your database, within your catalogs. So only the server can lock them and make sure the commit itself is consistent within the transaction. Because it's a REST spec, so the client implementation is actually much easier, right? Yeah, we see so many REST clients. If you look at the Iceberg repo right now, we have Iceberg Python, we have Iceberg Rust, Iceberg Go, and all this language has been enabled to talk to, in the very beginning, they only work with REST spec. Later, they try to explore more, but because REST spec is such easy to implement. We added some recent feature. We added some feature to the REST catalog recently. For example, with right now the REST spec support view, supports server-side planning. Server-side planning basically means you have, like normally engine does all kinds of planning. You have the SQ going to the engine side, the engine will do the logic planning and then go to the physics planning. So server side can do that. The benefit is if you can do from the server side, then the client side is much simpler, and server side can cache all these intermediate result in case you want to reduce that one, right? And server capability, it's more about compatibility things. Means we have like 10 endpoints for that REST catalogs, and this particular server implementation only support 5 of them, and then clients can make better decision other than try and error. And credential vending, credential refreshing. So this is very useful for production environments, especially when you're with the cloud object store. S3, you can the REST catalogs can finding all these credentials and do the refreshing of the credential without the fixed credential from the engine side. Otherwise, you have to specify this credential from the engine every time. And HTTP caching is added very recently. This is very useful, especially when you have a table with huge amount of version files, or your version file is really big. For example, some organization has these version files like more than like 10 megabytes, because they have so many snapshots being created within that version file. And every time you load that, every time it's really heavy for the networks. So the e-tag itself will help you out. For example, every time you send back the e-tag based on your metadata file location, if the table already changed, it will send the original one. If table is not changed, and it just does send, okay, not changed, you still have the latest one. And some future directions, the community still work on the fine-grained commits. This is very interesting. This is allow you to allow the catalogs to write the manifest file as well as manifest list file, basically snapshots, right? This is very useful, especially for abandoning use case when you have a huge amount of the file, small file or big file, one or two append, and in very frequent way, this will help a lot. In a server-side metadata table is another nice feature where when you guys use Iceberg table, you probably know that you can easily understand the internal of the Iceberg table by querying the metadata tables, like how many snapshots you have, how many partitions, how many like data files, how many data files you have. And if we provide server-side metadata table, then the client-side implementation will be much easier. They just call that API and it automatically gets all these nice metadata out. So next topic is about the compatibility. I think this is not only for the Iceberg REST spec, this is also for every REST spec. When we design a REST spec, this is one of the core design principle for REST spec design. And I think the community did a great job when we designed this REST spec. One of the principle is done based on the hypothetical use case. And every time we have a proposal from the community, and we always ask the question, what's your use case, right? Is the use case valid? And can we do something else to support that use case? So compatibility is core principle, and you cannot afford the constant, once you already have your REST spec out, all these clients and server will rely on their REST specs. You cannot afford a constant client update or even server update. And every time you update the server, you are not supposed to break the existing client, right? And the second principle is we strive for backward compatibility, right? So every time we design the specs, we try to do the minimal instead of we trying to do add as much as we can, so that every time you add new things to specs, it becomes a thing that eventually you can never get rid of. It's not necessarily never get rid of. It's really hard to get rid of. So we always favor addictive changes, new field, and endpoints over breaking existing one. And how does we have a 3 table spec versions: V1, V2, V3. Do you know how does one Iceberg REST spec support all of them? Most of the time we use different endpoints and different like optional field, so that when you use REST client, it always supports all these specs. And for example, if you have one field is mandatory in V1 and optional in V2 or other way around, well, we always make that optional so that REST client is always compatible with the server side. Still, there's some case where we need to deprecate something. For example, the token endpoints we deprecate, and there's some HTTP status code we deprecate. And every time we deprecate, we should make sure we communicate to the community very well. with clear warning, with the timeline, like which version we're going to duplicate that field or that endpoint, and with some migration paths. And another good practice is we document everything clearly in the REST spec, because we don't want ambiguity for the both clients and the server-side implementations. One example is the for 19 status code. It happened to the community that some Python client actually rely on that for the retry, but it's not it's not a kind of a mandatory status code. It's not a reliable to base on. That we're trying to document it well so that no client is relying on that. Last point is think twice before you propose V2. Like you always have the temptation to, okay, V1 is not good enough, I am gonna propose V2. It turns out versioning is very expensive, and every time you propose something new and the new clients had to be there, and otherwise nobody can use that version. So always think twice when you try to propose V2. That's pretty much about the spec itself. And once the spec's been released, and there's so many adoption there. For example, right now we have multiple server-side implementation, Apache REST, Graphene, hashtag the later they call it the keeper. And from client side, we have Spark implementation, Java implementation, Spark, Trainer, Flink. We have a Python implementation, Ray, Daft, and we have Iceberg REST and Go all implement these Iceberg REST spec. It's interesting that with more and more support, and right now the REST spec itself becomes a universal language to use your Iceberg table. So what I heard is the S3 team is working on the REST spec for the S3 table because they want the adoption to be up. This is not, by the way, this is not complete list. And Glue supports REST spec, and Nessie also supports REST spec. And this is one of the implementation called Apache REST. This new project is originally developed within the Snowflakes and donated to the Apache Software Foundation as the Apache project. Right now it's in incubating status. And other than all these new feature, all these cool feature within the REST spec, like multi-table transaction, views, HTTP caching, it's already supported within the Polaris. Polaris also provides very nice RBAC, role-based access control, and a credential vending. Without credential vending, you actually have to configure two sets of the credentials every time you visit your access your Iceberg table. One is for the catalogs, and another is for the storage, right? For example, S3 credential, right? And with the credential, you don't have to do that. And when you combine RBAC with credential vending, it's actually become a synergy that you have a single place to control your access for that particular table. You don't have to go to different places like S3 storage to configure your access control for your table and then go to the catalog, right? You have a single place to control the access for your tables. And even better, Polaris itself is starting to support more advanced features like fine-grained access control with policy, data management system, table management, sorry, the compaction, express snapshot, all kinds of table management schedules, procedures through the policy as well. All right, I think that's done of the true open source lakehouse with Iceberg as well as the REST catalog like Polaris. Thank you very much. These two links for these two projects.
All right. Thanks, everybody. And we've got time for some questions. So is there anyone out there who has anything they'd like to ask Yufei? Oh, we'll start right in front.
What is the ETA for the views?
ETA for the views within REST spec. It's already there. Yeah, it's already there.
Thank you. Thank you for a great talk. And I was wondering, what's the roadmap down like 2 or 5 years?
So yeah, 2 or 5 years, you're asking Polaris or RESTback? Yeah, for the RESTbacks, actually, I think there's not a big change where happen to the RESTback because right now it's relatively stable, and the RESTback itself is involved with table spec. Every time adding some table feature, then we're gonna have adding something into the RESTback. There's still a lot of room for improvement. For example, right now the range querying mapper table is not so efficient because you have to query each individual table and it's not an efficient way. So potentially we can add some more capability into that. For the Iceberg, for the Apache Polaris, there's much more than that. We can have tagging, we can have federation, catalog federation, we can have SSO, identify federations. We can have the policy, fine-grained access control for multiple different kind of compliance. We will have the table maintenance, event listening, all kinds of features. It's going to happen to the Apache Polaris. Sure.
Run back.
Okay, next year. So, see, right now for managed table, right? So we create a. So should we create a view in Snowflake, or we have to create in a catalog?
For managed Iceberg table rights within the Snowflake.
You're right. So let's say managed table is sync automatically, right, in the Polaris.
Yeah.
Correct.
So Polaris managed table.
So
you're
should
talking
we
about.
create a managed view which is not there in Snowflake? Then it will sync automatically, or we have to go do it separately in a catalog, Polaris.
Yeah, I think that's a good question. Unfortunately, I'm not aware of how the Snowflake view work with the. So right now you have the Iceberg view as being support within the Polaris. So you can always create that Iceberg view.
Basically, we have to go outside and create only.
Yeah, that's the problem. So the view itself, where right now it's living within the catalogs. If you use Polaris, so you can use view based on the table within Polaris. Otherwise, you have to do the federation to pull this table from another catalog within the Polaris to do the view definition. Yeah.
Okay, so we have to do it in Polaris.
Yeah.
Yeah, thank you for showing the history of this catalog. And also when the catalog is taking more responsibility and allows the client to do less.
Yeah.
You show one slide that overlap. Could that cause a potential issue? Like the client try to do and the overwritten by the server, or server try to write something overwritten by the client?
Yeah, that's very good question. So even there's some overlap in terms of the metadata written commits. There's would not be any issue because it's still controlled by the concurrency model we just talking about, the Iceberg concurrency model. Every time you do the commit, it will check the base version. If base version does not match, then it will fail and retry from either from client side or the server side. And the overlapping, that's a very good question. That's right now it's a little bit overlapping, but the potential issue is actually when catalog try to read more and more data, especially right now we don't talk about any data files because catalog is not built for that, right? Even for metadata files, we're gonna see the potential scaling issues. So that's the place where we are very careful not to too much even the manifest file because its potential will jam the whole Polaris service, the REST catalogs in general. Hopefully I answer your question.
Some question in the back.
Yeah, could you talk a little bit more about like catalog federation and kind of like the roadmap with the REST catalog or with Polaris on that? Like, what's your strategy for either kind of like migration or like federating to existing catalogs?
Yeah, that's a very good question. So let's split into the two part. One is from the Iceberg specs, REST spec side. We have something working in progress called an event, and we have something else maybe just in my mind, I just talk about the range searching. When you can query multiple tables with the metadata JSON file paths, so that basically it's right now the HTTP caching only applied to one single table, and we wanted the HTTP caching applied to multiple tables, so that when you query this huge bunch of tables, you can actually know that the one particular table or one out of the 100 table already changed without pulling everything. This is one of the area we want to working on to make sure we have a spec there so that everybody can benefit from that. This is actually one of the pain points when you try to grab some table from the other catalogs, right? You don't know if they are changed or not unless you load all this metadata. This is one area where we are working on the Iceberg REST spec. Another area from the Polaris side is Polaris is already starting to support the federation from another Iceberg REST spec, REST catalog, Glue, for example, Glue. And we're going to extend to the other catalogs like HMS a little bit later.
So when you, so in the follow up that on that one. So basically, when you do federation, right?
Mhm.
So federation, when we're doing from Snowflake, we have auto sync already there, right? So we can have a catalog integration. We can do that. So we get a namespace for database, schema, and table, right?
Yeah.
So how it look from HMS and Glue, like what your vision is there?
So right now, if you look at around the catalogs, so most of the catalogs only support three layers: catalog, database, and tables, right? Or you call it namespace, right? 3 layers. So the mapping between these three layer into the Polaris or any REST catalogs, especially Polaris, is there's no issue about that because Polaris support multiple layer of namespace. Actually, you can do mapping, one-to-one mapping to the Polaris with catalog, namespace, and tables. That's how it works. I think so right now. That part is quite straightforward. Unless you have, even you have the nested namespace in another REST catalogs, Polaris can still support that. It's kind of a superset within the Polaris to support this kind of mapping, namespace mapping, and table mapping.
But in Snowflake, it's one more.
Snowflake is 3 layer. Snowflake is kind of a strict 3 layer. Yeah, thanks.
Thanks, Yufei. Great talk. As you can see for all the questions, like it looks like Iceberg Spec is a separate initiative and the Polaris is a separate initiative. What is the roadmap to merge? Like you have some cool features in Polaris and there'll be cool features in Gravity. How can you bring them at one? Like that's what we see as customers, right? We see varied features in one catalog and the other implementation has a different feature. And there are very strong integrations in Snowflake and Polaris, but we'll not find others. So what is the roadmap to combine or give us one?
Yeah, that's a very good question. So ever since we develop something new within the Polaris, this question always come into our mind first, like whether we should put it into the Iceberg REST spec or we consider as the catalog feature. It's separate from the REST spec. So there's some nuance there. So in terms of the Iceberg REST spec, it's focused a little bit more on the table side. It does not try to go to the catalog side too much. So for some of the features, especially about the policies, seems like there's no good point to put into the Iceberg REST spec. And the Iceberg community also do not like it to within the Iceberg REST spec. So it's more about catalog features you try to build. So that's a place where you can put into the Polaris because Polaris is also Apache project, right? That's also what we did. Put the policy rates, the spec within the Polaris. And the Polaris itself is trying to support more than just Iceberg table, like generic tables, etc., and volumes, and for all kinds of these stuff, because it's not related to the Iceberg table, then of course it's gonna be the Polaris side. But we do think a lot, like every time, if there's some overlap, we want it to be in Iceberg to increase the interoperability for the whole community, benefit everyone, instead of just putting into the Polaris.
All right, do we have any more questions? All right. We should probably end with that then.
This may be the last one.
Okay.
So you see, you have the multiple role structure, right? So you say, use Polaris as a centralized access control, right? And then that should be the lake house in the centralized for the whole org, right? So if you see in Snowflake, we have multi-levels, or other database, we have multi-level roles. But in Polaris, if you see, we have only one level, right? And then second level is maybe a principal or a role we granted, right? So how that I think I heard from Steve and other guys too. You guys have a sync between role structure to Polaris also, right?
Yeah.
So that's one question: how you multi-level come in one level here, and then other question: how HMS access will Ranger end up here?
Yeah, I think that's a very good question. So the identity federation is something we really wanted to resolve within the Polaris. It's right now there's no solution work out of box. We are working very active on that. In terms of the mapping, I think we have to think about mapping. So essentially, you're talking about identity federation with users, which is principal, as well as the roles, right? We don't. You can sync roles, but a lot of times we don't sync roles, because if you have a role in Okta, that particular role does not have any privilege on the Iceberg tables within the Polaris, right? We still have to create a separate role within the Polaris to make sure that particular roles is a group of the privilege on your tables or other data asset, right? So you can always sync the principals, and we still have to make sure this particular right role attached to that principals. I think multi-layer, I'm not sure, essentially just the principal, you have to make sure your principal is correct across multiple systems other than anything else. Yeah.
I think we should, we'll pass on that. Yufei will be available to answer more questions in the hall.
I
don't
can
want us to have
offline.
too many
I can answer
Snowflake
question
specific
offline.
things going back and forth. Thanks everyone for attending, and of course, check on your app. You can rate this this talk and all the other ones you see today. It's really important for us collecting feedback for next year. And I'd like everyone to give one more round of applause for Yufei, and thanks so much.